Hey everybody, this is Scott. So I would take the time to do another tutorial here, and this is going to be pretty different from my normal tutorials in that it won't be related to Ember whatsoever. But specifically, I get a lot of requests for like API related stuff in Ember, so Ember data related stuff, authentication, relating models and stuff like that. And honestly, it's kind of hard to come up with examples of that because they're typically full stack problems. So I thought, I'm just going to go and create a kind of simple JSON API. I'm going to host it on Heroku so that when I do these tutorials, I can kind of have one source that I'm always working with. That way I can personally just mock up some endpoints and then maybe work through some examples. So as I was doing that, I thought, I should just record it while I'm building that API in case anybody may find that useful. So if you specifically watch my channel just for Ember stuff, maybe this doesn't speak so much to you, but we're going to build a pretty simple JSON API using the Phoenix framework, which is written in Elixir. So if that's something that's ever interested you, maybe you'll get something out of this. We're not going to go super in-depth, and we're going to create just a read-only API because I'm going to host this locally on Heroku, and I don't need a bunch of people writing data to my test database. It's just going to return a couple models, and maybe I'll add some more to that stuff over the course of my tutorials. But if you've ever been interested in writing a JSON API yourself, definitely check this out. Hopefully that this speaks to you. So for me, Phoenix was my first backend framework. One issue I have with a lot of tutorials and videos I see out there is a lot of people compare it to Rails, and certainly a lot of Phoenix developers came from a Ruby on Rails kind of environment, and I didn't. So when people would say things like, oh, well, in Rails you would do this, and this is how we duplicate that in Phoenix, that made no sense to me. I didn't really have the context. I'm mostly a front-end developer, certainly. That's what I do for client work. So I can't go super in depth into all the reasons why you would want to write Phoenix, but maybe it's just a technology you've heard about, you've been interested in. If you need to do lots of concurrency work, that's really where Phoenix shines. So anyway, we're going to follow pretty simple generators in Phoenix. This is once you have Phoenix installed, we can call mix phx.new to create a new app. If you're wondering why is it not mix phoenix.new, Phoenix spelled out, that's going to be the old generators. So the new Phoenix apps use what are called contexts, whereas the old Phoenix app, you'd see things very laid out very traditionally, controllers in the controllers folder, models in the models folder. Very similar to Rails, actually very similar to Ember as well. And the new kind of Phoenix format is they're trying to get you to think of things in contexts, and I'll go into more details when we get there. But let's, for the time being, just create a new Phoenix application. So mix phx.new, and we'll call it project management example. So goes and creates all these folders that access. Do you want to install your dependencies? We'll say yes. And if you're coming from front end, you've never worked in the back end, think of Mix as kind of like the NPM. It's going to install your dependencies. It can have some generators for you as well. And this could take a few minutes. Cool. So that might have taken a minute or two to run, depending on how fast your computer is. But if we look in this folder, we'll see we now have our project management example directory. And I'm going to initialize a Git repository, so just git init. There we go, and now you can see, because I use ESH, kind of tells me what branch I'm on. Certainly don't have to do that, but I'm going to push this stuff up to GitHub so you can kind of refer to it if you want to. So maybe let's just add all that. We'll just say initial commit. Cool. Let me clear this out. All right, so let's see what this created for us. So we have a few directories here. The first thing I want to direct you to, though, is the config folder. So we're going to be using Postgres as our backend database. So if you don't have Postgres installed, you'll want to go and do that. And the way it works is with Phoenix, it's going to create a Postgres database named after my repository, so project management example, and then it's going to underscore it with a dev. That will be our development database, and then it'll also do one for test. That would be our test database. So what I want to direct you to is the config/dev exs file, and down here at the bottom, when they are setting up the repo, so Ecto, think of Ecto as kind of the middleware. That's what communicates with your database. It's going to communicate with Postgres. So Ecto has specific adapters. So if you don't use Postgres, there are other databases it supports, but for the purposes of keeping it simple, we'll go with Postgres. So down here at the bottom of the folder, you'll see stuff for your Postgres, a username, password that might be different on your computer. So that's just kind of why I wanted to direct you here, because you might need to change this to your computer's username, your computer password. You might need to set up a role within Postgres itself. So database, like I said, will be the name of our repo with _dev. You can call this whatever you want, but I recommend just following the convention. And similarly with the test environment, we're not going to be writing tests in this example, so we can just skip over that. So what we want to do is we want to create two models. So I'm going to call them projects and documents. And a project can have many documents. So a document belongs to a project. And we just want a JSON API. We're going to hit an endpoint. It's just going to return some JSON in the JSON API format for us. So in order to do that, we need to generate some JSON. So make this a little bigger. We can do mix phx, so Phoenix gen JSON. So now comes the idea of contexts. So think of a context as something like an umbrella that just is like an encompassing name that can relate to a few things. So the common example, like most web dev common examples, is blog. So let's say my context is blog, right? So what encompasses a blog? Well, a blog has posts. So a post would be a controller, like a model too, that is in the blog context. It can also have authors, authors of those posts, commenters, things like that. So a context has multiple controllers, multiple models, but the context within Phoenix kind of becomes like the public or the consumable API, and I'll show you what that means. So we're going to call our context management. So when we generate JSON, the first argument that we want to provide is the context. Then it's the name of our model or the name of our controller. In this case, project. And then Phoenix wants you to specify what the plural name of that is going to be as the next argument. So we'll do projects. Then next we want to specify the actual attributes. Now we don't have to do this here. It's just going to generate the boilerplate for us and make our lives a little bit easier. So we'll have title, which is a string, and a description, which is text. So those are going to be the types applied on our database. So string type, description is a text type. Those would be the fields on our Postgres table. So let's generate that. And it looks like I don't think I can have spaces actually. So there we go. Cool. So now that's generated, let's see what that actually created for us. So in our code, the thing we typically want to focus on is in this lib directory. So project management examples, like the encompassing name of our application, project management example _web, is the web interface for our app. And that's what we're building, a web interface, which is our API. So you'll see it created that management context for us. So if one doesn't exist, it will create one for us. And here you'll see a bunch of boilerplate code. So in our project, so again, this is encompassed in the management directory. If you had written Phoenix prior to version 1.4, you would probably see this structure within the models directory, and they kind of moved away from that. They don't really want to call things specifically model anymore. These live within a context, so the management context owns this, but for all intents and purposes, this is our model. And again, if you're coming from Ember, think of it the same way. This will hold logic specific to this model. It has the list of the fields. So those are the two things that we created. So you'll notice here, description says string instead of text. That's because there is no kind of text model type. It's still considered a string when it's returned in JSON. It's considered a string. Text really only applies to the database. Timestamps, it's just going to add 2 fields, which is created at and updated at. So that just comes free with every single model that we have. Change set, I'm not going to go into too much detail here, but change set's one of the coolest things about Phoenix. When we are creating new records, and again, we're going to create just a read-only data API here, but a change set literally just tells us what has changed when we get attributes pushed to us. So when we have a post request or a put request, change set will actually highlight what has changed. It will tell us the actual errors. We can set, this is where we would set validations too. So if you're not familiar with pipe operators, this is probably one of my favorite things with programming. Typically you would have a function, let's say it's get user, right? It accepts an argument of some ID. Then when you have that, you have another function that is get profile, which requires a user to be passed to it. And then when you have that profile, you want to update the name, update profile name, and that takes a profile itself. So if you were to write this out, it would look like this. Right? That's kind of how functions work in general, right? Inside out. So this is executed first, and then it comes out, and then out further. Piping, what it does is it takes the result of this and passes it as the first parameter to this function. So we could write this like this. So since the result of this is now the first parameter of this function, we can take this out. And now we can take all of this out as well, and that's how it will read. And this kind of makes more sense because this is the order that that these functions will fire. It is inside out, but it's just a nicer way of writing it. There's definitely a lot more documentation on piping within Phoenix. Definitely encourage you to read that. This is certainly not an elaborate overview here. So let's now go to the web directory. And we have 2 things that were created for us. Channels and templates we're going to ignore for the sake of this tutorial, because again, we're just returning some JSON from an API. So now we have our project controller, and you'll see, oh my god, there's a bunch of gibberish here. We're really just focusing on index and show. So these are our API endpoints. The index endpoint returns all or a subset of our model. For our purposes, again, we're just going to return all of our projects. Show returns 1 based on an ID. Create would be the create endpoint. Update would be update, but again, we're going to skip over that. So this is where context comes into play. So we are aliasing the name of our context. So if we come here, that's the name of this module here. Project management example.management. probably could have named that better, so I apologize. But that's what we're aliasing here, and aliasing just means that we can now write it as management instead of project example.management. So you'll see the index, what it does is it creates a variable called projects, and it calls this list projects function. So this is what I was talking about when our context, like our umbrella context, is the API that we're going to consume. That's where we write our functions for fetching data, updating data ultimately. This is just kind of like the public web interface, but all of our logic is going to live on the management context. So list projects, you'll see all it does is return all of our projects. So repo is what's going to communicate with our database. All is pretty self-explanatory, and then we just pass it the name of a model, which in this case is projects. Get project is what that show one does, and repo.get returns a specific one that expects an ID as the second argument. And again, I'm going to ignore the other CRUD actions for reading and updating, or excuse me, creating and updating. And then finally we have our view, and we're just going to focus on this one, and this is what controls how our data gets returned, our index.json. So again, the JSON for our index endpoint, how we render it. We're going to render many projects with the project view being this file that we're in, and then this controls what attributes are actually getting sent. So we could have a bunch of fields on our database, or a bunch of fields on our model, but maybe we don't want to publicly expose that to our users. This is where we can control that. Like we could take title out, so only description is returned, but we're going to skip that for now. And then finally, because we're going to ignore tests, like I said, what was created here was a migration, because obviously we need to update our database to have this table. And that's what this file does. Creates the projects table, and it creates these two items, and again, timestamp is updated at and created at. So let's come back here, and let's create our database. So if we type mix ecto.create, we get a compilation error. And the reason for this is a little finicky, and it's slightly annoying to me that we don't catch this with the generators, but it's trying to call this function here, project path. For now, like I said, we're going to ignore this create function. But I will go over why we get that error in just a minute. So this created the database for us. So if you were to log into Postgres, you would now see that dev database. And now we want to run that migration, mix ecto.migrate. So again, ecto is the thing that communicates with our database. So now we have a new table in our database called projects. Great. So again, the idea of our API here is that we just want to return some JSON, and what gets shown to the user is controlled in what's called the router. Very similar again to Ember, very similar to Rails. This is kind of our public interface here. So you'll see there are two quote-unquote pipelines. Browser, because you can actually create HTML apps with Phoenix, as well as API, and that's what we will be building. So we can just ignore this for now, because again, we're not building HTML, and what we want to comment out is this: scope API project management example web, which is looking at this directory, and it's going to pipe through this. It's going to pipe through a pipeline, which is defined here, and this tells us that it accepts and expects JSON in the payloads. So we want to, again, we want to return all of our projects as well as one specific project if we give it an ID, and you can do that with what's called resources. So this scope here is at the actual URL. So when you run this, you'll go to your app's domain /API, and then we can define a resource, resources /projects. So that means it will then go to our domain name /API/projects. We'll make a GET request or POST request, and we will bring in that project controller that we created. So this name will match this, the controller here. So it expects everything to be namespaced in this. So project controller under the project management example web namespace. So that means if you have another app of a different name within the same repo, this scope will not find it. It wants it to be under this namespace here. So this alone will work. Resources, what it does is adds all the normal CRUD actions, which in this case is index, returning all of them, show, returning one, creating a new one, or updating an existing one. Again, we are only doing read actions, so we can specify only the index and the show. Now, if you wanted to define these differently, you can also do get /projects, project controller, index. And the reason you would do it is if you wanted to do something atypical. For instance, this is what it expects show to be. So it expects an ID to be passed to it. So resources, what it's going to do is allow you to use its default behavior. If I wanted to overwrite that, that's when I can say, no, this is going to be a GET request to the project's endpoint, but I'm actually going to pass it a slug. I'm not going to pass it an ID. So now we're finding it by something that's not the ID. We're doing something atypical. So in this case, I'm overwriting it. A lot more documentation on that. Again, not meant to be super in-depth here. So resources, projects, our index, endpoint. This should be all that we really need to do here. So let's run our app mix phoenix.server, and it will run on localhost with a port of 4000, localhost 4000, and again API/projects. And there we go. That is our API. And it is returning all of our records, which in this case isn't much. And it returns it in the data hash. And that is specified here in our view. So this is what it returns, data, and then it renders many. Pretty straightforward so far. We have an API with an endpoint that returns some data. So next, let's actually put some data in this database. And I'm going to do that just by creating some seeds. So you'll see here, Phoenix provides a seeds template for you, and it even tells you how to run it. But these can live anywhere that you want them to. So I'm actually going to create a new folder called seeds, because I'm going to create one for every model that I have. And we're going to create a new file called projectseeds.exs. So we want to call that repo that you see in our lib directory so much, repo.all. We're going to call repo.insert. So repo belongs to the name of our project, project management example. So again, we're also going to alias this just so that we don't have to write the whole name out every single time. And we're going to do the same thing, but with our project. So again, this is the name of our model. It lives under our management context, which is part of our app. So now that we have access to repo, we can say repo.insert. We use the exclamation point because that will throw an error if something happens. And we are inserting a project. And we're going to give it a title, which is super cool project, and a description. This project is the best project ever. And just to save time, I had a few of them created. I'm just going to copy and paste them real quick. Cool. So there's some projects. We're going to run the seeds. And again, this kind of boilerplate seeds tells you exactly what you need to do. Mix, run, and then the path to your seeds file. So tutorial, what do I call it? Project management. Let's make this bigger. We will do mix, run, as in priv, repo, seeds, project seeds. There we go. It's inserted into a green text, is always good. You can see the actual SQL commands here, and if I refresh that, I have a JSON API returning 3 models with IDs, descriptions, titles. By default, the IDs will be auto-incrementing integers. If you want it to be something else, that's something you would specify in that migration file. You can overwrite that pretty simply if you want to use UUIDs or slugs or whatever, but for the sake of this tutorial, again, we're going to keep it really simple. Awesome. So we have a really basic JSON API right now. To do it a little more longhand, let's actually go and create one more model called documents. So mix phx.gen.json. It's going to live in that management context. It's going to be called document. Let me make this bigger again so I don't run out of room. Then it expects the plural of the name. So last time we created it, we specified all of our field names within the CLI command. So let's see what happens if we don't do that, because maybe we don't know immediately what's going to happen. So here it's noticing that things like change set view and fallback controller are already created. It wants to edit those files to include this new model, so we're going to say yes, go ahead and create that. So it created all the same files that we had before, but it didn't have the field names that we wanted. So let's start by looking at the migration. So here's our migration. The change is what happens in the change. Similar to Rails, if you're familiar with that, you can also do up and down, which is up is when you run the migration, and then down is if for whatever reason you need to roll back that migration, what happens. Change is good for really simple commands, adding tables, adding columns, where Phoenix can know pretty simply what it needs to do, or excuse me, Ecto knows what it needs to do to roll back those migrations. So just keep that in mind. So we are going to add these fields ourselves manually. So add name string. So we're going to add a name field. Maybe we'll have some content, which, similarly is a text field, just like description. Maybe we can track how many times something is viewed, view count. That's an integer. And then we can add a published, which is a Boolean with a default value of false. So we can have a few different fields there. But next, we also want to relate documents to projects. So we're going to add project ID, so that would be the name that it would have on our database, and that references projects. So this name here should match this name here. So we'll go ahead and save that. So now if we do mix ecto.migrate, you'll see we get this error document path again, saying that that function is undefined. Again, this comes from the create method, but the reason that it happens is that's something that's created dynamically when that controller is put into the router for us. So if I were to duplicate this but do documents, call this document controller, I shouldn't get that error again, and I don't. It is annoying. It actually took me a little bit to figure that out the first time. But if you run into that, either just comment out the create function if you don't need it right now, delete it if you're not planning on using it, or add that controller to your router, in which case that path of that model will be created dynamically for you. So now that we've added that to the router, let's take a look. So our call to that endpoint fails. That's because we still have to do some setup here. So let's start by going to our management context and looking at this document file. So you'll notice here the schema is blank, whereas here it was pre-filled for us because, again, we specified those field names when we generated the file through the CLI. We didn't do that this time. So let's add those fields that we created. And let's go and look at that real quick. Copy these. And then just paste them here. These will all be field. So field name, same exact format. The only one that has to change here is text. I don't believe we need to specify that it's a default of false. And then I'm going to move this down because it's a relationship just to separate it. So this would be a belongs to. And rather than references, and rather than specifying that it's an ID, we are going to say it belongs to the project table or the project model, and that lives in project management example. So again, the name of our project. It lives under that management context, and it's called project. So here in our change set, this controls what will actually be considered valid to pass to our serializers, valid to update, and so we need to list those fields again. So name, it's going to cast these fields, content, view count, published, and project ID. And validate required would be any fields that we feel like are required. So this usually typically applies more to those CRUD actions. Like if someone is creating a new record, we can throw an error if they don't have a name, for instance, because we're going to say, no, name is required. All the other ones can be empty, but name has to be there. So we went and created that. So now let's finally look at our views here. And this is where, again, much like the project one that was added by default, we want to add those fields there as well. We just hit enter, oops, name, document is the name of the instance here, and this needs commas, right? Yeah, this needs commas. We had published, document.published. We had content, which is document.content. View count, which is document.viewCount, very repetitive. And then the project ID, which is document.project ID. Great, so let's try refreshing this. And we're still getting that document path function is undefined. Make sure I typed everything right. See if I add this in, will it? Oh, interesting. I thought that I didn't need it, but if I add it in, it does create the path. And if I take it away, it doesn't. Oh, now it does. Maybe it was cached? Oh, I'm not sure. Yeah, that must have been some sort of caching issue. Great, so again we have this. Similarly though, let's add some data. So we're going to duplicate this. We're going to call it document seeds. And again, just for the sake of saving time, I had a bunch created. I'm just going to go ahead, copy and paste them. So in this case, we're also inserting the relationship that we want. So I'm going to have two of these documents that relate to the first project, only one relates to the second, and then two that relate to the third. So we can do mix run, and then the path to that seeds file, document seeds. Documents seeds. You rename that because that's not a good name. Oh. Well, that's why I spelled manager instead of management. Excuse me. So one more time. There we go. And it's inserted that. And now if we come here and refresh, there is all of our data. So 2 endpoints. Pretty basic JSON API. Alright, so if you notice one thing though, although this is an API and it returns JSON, it does not return the JSON API spec. And in order to do that, we can certainly write it out ourselves in those view files. Again, it's data and then it returns an array. We could write it all out ourselves, write some hashes, but luckily there's a really nice repository that we can use called JSerializer, and in order to add that to our project, we update what's called our mix.exs file. So again, if you're more front end like me, think of this as like your package.json. This is what npm looks at, or that's what npm looks at. This is what mix looks at to install dependencies. Oops. So we're gonna grab, it's a project called JSerializer. You can look it up at GitHub if you want to. I've used this on every single Phoenix project that I've worked on because I always work with Ember in the front end, and Ember works best with JSON API, the JSON API spec. It's much more opinionated, but it's nice because it just sends so much more information. So how do we set that up? Well, first we need to install it. So let's kill our app here and do mix deps.get. So that will install our dependencies. We can do mix deps.compile. So we'll recompile our dependencies, make sure everything is installed. There, generated JSerializer app. Cool. So mix phoenix.server. We'll run that app again on localhost 4000. So the first place to start is, in fact, our router, because you'll see plug accepts JSON. So let's actually write a new plug, or excuse me, a new pipeline, and we'll call it JSON API. And that will plug, by the way, accepts JSON API is our spec. And we also plug through a serializer and deserializer that JSerializer offers, because that's really what this project does. JSerializer dot deserializer. And not sure why I added an extra line. Oops. There. So now we want to pipe this through JSON API. So if we come back here and we refresh, we're still getting the same thing because we still have more work to do there. So we can come to, let's look at the document view. So we now want to use JSerializer.phoenix view. So this is going to give us pretty much all of this stuff for free, but it's going to follow the JSON API spec. So we can actually delete this. We can delete this as well now. So again, it's like almost like a mix-in. It's just already defined all those functions for us. But like I said, we could take the time and write it out the way that the JSON API spec expects us to, or we can just use this view, which has it for us. The only thing it wants us to specify is the attributes that we want serialized. So similarly to how we wrote them out down here, we need to still write them out here, otherwise Just Serializer doesn't know which fields to ship and which ones to ignore. So name, published, content, view count, and a project ID. So if I come back here now and refresh, great. Now it follows the JSON API spec. And we're going to do the same exact thing, but with our projects. So we'll delete all of this. And attributes, it's an array, title, description. So now if we go to projects, following the JSON API spec provides a type, the ID is outside of the attributes, so we get our attributes hash. Now we have a JSON API. If we look here though, you're going to notice we get they're essentially deprecation warnings or kind of linting errors. Please use index.json API instead. This will stop working in a future version. So that comes from, that's coming from this. So index.json is the kind of default. We want it to be json.api, right? Because we changed the R spec there, and we want to do that with this as well. -API. So if I save that and refresh this, something blew up. What am I doing wrong here? Let's look at this again. Passing data via model. Oh, that's right. Again, it's just another deprecation warning. It expects this to be data. So this should be data, because that's what the JSON API is always going to pass things in the data hash. So let's save that and refresh. Okay, so now we're down to one deprecation warning, and I could have sworn it was this. No clause matching in plug con response 3. Okay, so I'm going to kill the server, and I forgot that I had done this on another project. It expects us to update the MIME type for a JSON API. So go to your config folder and open config.exs, and this is where we can set up lots of things about our projects, where it's hosted, secret key base. This one was generated for us randomly, but we can see when we deploy a project what exactly this does. And we want to paste this stuff in, and if you go to the documentation for JSON Serializer, it does actually say this. I just ignored it. So if we do that and then come back and restart our app, because you will have to kill it anytime you update anything within this config directory. There we go, and now it works, and we don't have any deprecation warnings. This again needs to be data, and this can be changed to data. Cool, so that should be it. We'll go to our documents endpoint, just make sure that everything's looking right and we're not getting any deprecation warnings. So there we go. Pretty simple JSON API using Phoenix, and we can use this with our Ember front end. So like I said, the whole idea of this was I just wanted to create a simple API that I could refer to in some of my other tutorials. I'm going to push this up to GitHub so you can go ahead and pull it down. You'll obviously have to install Postgres and you'll have to install Phoenix, or Elixir, which is the language that we're using. And again, this wasn't meant to be a super in-depth tutorial, but hopefully you learned something from it. And now we can go over hosting this repository on Heroku. So I'm going to go ahead and add everything. Really big commit with a bunch of stuff. Cool. So what I'm going to follow pretty strictly is the deploying guide on the Phoenix website. So if you just go to hexdocs pm phoenix/Heroku, you can actually learn how to deliver something to Heroku yourself. So we can kind of step through this really quickly and literally just read through the document. It's super helpful, and it walks you through absolutely everything that you need. If you don't have a Heroku account, you're going to have to register for one, and you're going to have to install the Heroku tool belt. If you're on Mac, you can just do that with Homebrew. And now we need to follow these steps here. So we're going to create a Heroku build pack. One is already created for us. We're essentially just pulling it down. And this URL here is where our app is ultimately going to live. So let's just leave that URL up for now. And let's keep going through this guide here. So we now need to run this command, which adds the build pack. And you can see we're still getting the same exact messages here. So now we need to make this project ready to be deployed to Heroku. And again, just recommend reading through this, but we need to set up environment variables that Heroku expects, because it's not going to read secret files. So a lot of times with Phoenix, you'll create a secret file that's not checked into source, and you'll have some sort of script that deploys that. And we're not going to do that, so we're going to set we're going to set these in the project itself. So let's copy this, and we're going to copy this right into our prod.exs, because we're releasing our prod environment. And we want to just paste that here. Oh, it's actually just asking me to add this one line, so I got a little ahead of myself there. So we're going to do comma, and we're going to add this line. So we're adding that to, again, our prod exs file. Let me delete all this kind of boilerplate comments. Feel free to read through them if you're building an app, but just to kind of clean this up. There we go. It's going to make that a little bit easier. Then we'll add the production database configuration. So let's just copy this, but we'll have to remember to change hello to the name of our project, which is project management example. And we will save that. So now is when we actually update that URL. So we're going to replace this line, paste this in, but again the host here is going to change to that one that was created on Heroku for us. And we just get rid of the HTTPS because that's specified in this scheme. And we can get rid of, like I said, Heroku's not going to support the secret files. So normally this would be when you would import any app secrets that you might have. So that's what our file looks like. And it wants us to add a timeout to socket connections. We don't have sockets here, but we'll add it for good measure because Heroku will time this out at 55 seconds. So we'll go to the user socket and we'll just say timeout 45 seconds. And you can read more on this, but we need to create a file called Proc file, which Heroku expects with just this text in it. Oops. So let's just go here and say new file called Proc file, and we will save that. So now we're going to run this command to set up Postgres in that environment. Cool. And then we're going to set up the pool size. So this is the number of connections that we're going to support at any one time. Heroku limits us to 20, so we set it to 2 below that in case we ever want to log in and run any tasks ourselves. And that's what this paragraph here is talking about. So we're going to generate a secret, and then we're going to use that secret when we create or when we config our app. So we're going to set that close all of this stuff. So that is what this is. So we're setting an environment variable. So this isn't going to be in the video itself because obviously it's a secret. But just follow these steps if you want to deploy to Heroku. It is a required step. So now that all that stuff is added, just go ahead and commit that. And now we can push to Heroku. And this might take a couple of minutes depending on your connection. Alright, so it failed because, like an idiot, I called it hello. So, this should be the name of the project, and I copy and pasted the one from the example. That was not right. So let's add, and we'll just amend our last commit. We need to git push to Heroku again. And again, this might take a few minutes. Great, so once that is finished, you should be able to go to your app, go to /API/projects, and that is because we actually haven't set up the database. So once that is all set up, we have to keep following the guide and run our migration. So pool size equals 2, which is, again, because we freed up 2 concurrent logins. Because we only have 20, we set up our pool size to 18. We just want to make sure that we don't exceed that. And then we also want to run those seeds that we had. So Heroku run, again, pool size equals 2, and then we'll mix run priv/repo/seeds/project seeds.exs. So this is just so that we have data in our database. And then let's do it again for document seeds. And come here and refresh, and there we go. Our JSON API live on the internet. We go to /documents, and we can see all of our data there. So again, this really wasn't meant to be a super in-depth Phoenix tutorial. It was more I was going through it to have an API example for some of my Ember tutorials and just figured, hey, you might as well record it in case anybody's new to Phoenix or was just curious. But all in all, it's pretty painless for deploying a JSON API. Phoenix, ships with a lot of great blueprints for you. If you're not doing anything super complicated, you can get one up and running in less than an hour, as you can see from this video. just really recommend following this, deploying to Heroku. It walks you through everything that you'll need. You really don't miss a step there. So if you liked it, let me know. If you had any questions, feel free to comment. Happy to do more Elixir tutorials. People are interested in that. I'm certainly not an Elixir expert, but that is, something that I work in maybe about 10-15% of the time. The rest of my time is spent in the front end. So yeah, definitely let me know. Hopefully you learned something, and we can start using this API going forward in some future tutorials. Great, thanks.